All right, y'all, welcome to lesson 6.4. It is all about polarity of molecules. We have alluded to polarity in the past with a couple of videos. Um, Basically, just a brief definition is the polarity of a molecule means that it has a positive end and a negative end. So the charges are not evenly distributed, but they congregate, the electrons congregate more on one end of the molecule, making it more negative, while the other end is more positive. Um, so starting up here in the upper right, so what? Like why, right? Well, the polarity of a particular molecule is very important in determining how it behaves and how it interacts with the other molecules around it, right? If it was just neutral, it might not interact at all. But because it has some positive and negative ends, like here you see an oxygen bonded to a hydrogen. There's a partial positive charge here at the hydrogen, a partial negative charge at the oxygen. And because of that, this will interact with the molecules around it in a different way than it would if there weren't those charges. So let's define a couple of things that have to do with polarity. The first is called a bond dipole. Um, if we have a single bond, it can have what's called a bond dipole. The bond dipole is a measurement of the electronegativity difference between two atoms. Electronegativity difference. Remember, electronegativity, we've defined it a couple of times. It is the ability of an atom to pull electrons to it. Okay, so that dipole is the measurement of that electronegativity difference. Basically, you can calculate it just by finding a periodic table or a table that has electronegativities on it and subtracting to find the difference, right? That's a math word that means subtracting. So what this is a measurement of how unequally the atoms share those electrons. So if the dipole is very high, if the difference is very high, then the electrons are more congregated to one end. If it's very low, then they're less congregated. And if it's zero, then they're evenly distributed throughout throughout the molecule, sorry. The bond dipole arrow, you see, which is drawn here in this molecule, always points toward the more electronegative atom. Electronegative. So you can see here it's pointing towards the oxygen. Oxygen is more electronegative than hydrogen. Frequently on the arrow, they'll put that little plus right there to show this is the more positive, this is the more negative. You might also hear or read the term dipole moment. The dipole moment of a molecule is the net dipole moment of all of the bonds. So if there's more than one bond, like here in water, there's a bond between this hydrogen and oxygen and one between this hydrogen and oxygen. And you can see both the dipoles point to the oxygen. So the dipole moment is the net difference, which means basically if you take these two arrows and average them out, then the direction is in that direction, right? If you could average both of these arrows, you get a electronegativity difference pointing basically straight up as this is arranged, as opposed to on an angle like these two. Right. So like it says here, molecules with a dipole moment have areas that have partial positive charge and other areas that have a partial negative charge. So the positive partial charge in water is on the hydrogens. The partial negative charge is on the oxygen. Water is a very polar molecule, which basically means these bonds are very strong. It is very difficult to break the bonds between two water molecules, which is why water has such a high boiling point, right? It's 100 degrees. It is very difficult to break those bonds because of the strong positive and negative. It's also what makes water a very good solvent, which means it dissolves a bunch of different things because of the positive negative difference here. It will dissolve more things and pull them apart. So the negative, let's take sodium chloride for example, right? You have NaCl. The sodium is positive, the chlorine is negative. Well, with this water molecule, with these negatives and positives being so strong, the sodium is more attracted to the water than it is to the chlorine, to the oxygen end. And the chlorine is more attracted to the hydrogen end of the water than it is to the sodium. So it would rather be over here with the hydrogen, and the sodium would rather be over here with the oxygen. So the salt gets dissolved, it gets broken apart. And a lot of other things work that way in water too, because these negative and positive charges are so strong. So, it's kind of a summary definition. If a molecule has polar bonds and is not symmetrical, METRICAL, it will have a dipole moment and is called a polar molecule. So you see how water is not symmetrical, right? I can draw a line right here. It's different above and below, right? Polar molecule, because it's not symmetrical. It's one way to just look at them and tell. Alternately, you see these two nonpolar molecules. No matter which way I cut this one through the middle, it looks the same on both sides, symmetrical, right? Same with this one. No matter which way I go through the middle, this way or this way, it looks the same on both sides, symmetrical. So they are nonpolar molecules. Right? So a molecule has only nonpolar bonds. The molecule is nonpolar. Also, if a molecule with polar bonds is symmetrical, so that those directions cancel each other out. You see that? One going that way, one going that way. Remember we talked about the net. It had to be the net. Wherever that was. Net. There it is. So when you add these two together, they cancel each other out, right? So these are nonpolar molecules.